Okay, the first one, okay, when we need to calculate the area of parallelogram. What is the meaning of parallelogram? So means that if you are having kind of like this. Okay, so this is parallel to this one. Okay, left and right, and top and bottom are parallel to each other. Okay, especially if you are having a point lah. Okay, where we are having A, maybe point A, point B, here point C, and here is point D. Okay, for example. So by calculating the cross product, okay, where you find AB for example, and then AC. Okay, once again, remember our vector must be pointed outward. Okay, let's say we consider at this point A. So you need to find the vector of AB and also vector of AC. Okay, once you get these two vectors, then you calculate the, what we call it, area here equal to parallelogram, equal to just the cross product between AB and also AC. Okay, but you have to remember, since our cross product, we are getting a vector. Okay, so say okay, this case we find, okay, we need to determine the area, so we just need the magnitude of this resulting vector. Okay, so we put this magnitude lah, modulus. Okay, then you get this area of parallelogram. The second one, okay, using this cross product, also you can calculate the area of triangle. Okay, same goes to like this lah. Okay, let's say if we cross this, so you are having a triangle ABC, or you are having triangle BCD. Okay, so this one parallelogram ABCD. But now for the area of triangle, basically that is just half from our parallelogram. So this is equal to triangle. Okay, this is A. Can you hear me?
Answer.
Alright. Okay, thank you. Okay, ABC or BCD. So that is actually equal to half of your AB cross AC. Or for BCD, you can find calculate half of what we call it, maybe BC BD or DC DB. Okay, it doesn't matter. DC cross DB maybe. You are having many ways how to get this area of triangle. Just we put half. Okay, because basically half from this parallelogram. Okay, right. So you just perform the cross product and then you calculate the magnitude itself, because area we are looking for the magnitude on the scalar. Okay, we are not need the direction. Okay, so that's the application of cross product. Okay, the direct application. So now we want to focus with the your syllabus here. So the two application that you are having in your syllabus. The first one, what we call it as line in space. So this is B, okay, number 3. So I put number 4. Okay, line in space. So line. So just straight line. For example, like this, or like this, or horizontal, or vertical. As long as that is just a line. Okay. So for this line in space, so we are having several things that you need to know. Okay, the first one, so I put it as A lah. Okay, equation of a line. Okay, for equation of a line, okay, how can we find equation for this line? How about this one? How about this one and this one? So we are not sure either our straight line in this direction or this kind of slope around 20 degree maybe, or horizontal, or this slope around 135 maybe, or this vertical. Okay, and the most important, okay, to find the equation of your line, so we are having two, what we call it, two form of the equation. The first one, okay, a parametric equation, and the second one we call it as symmetrical equation. Okay, and parametric equation basically, okay, based on the name, we should having our parameter. Okay, parameter. What is our parameter? So for the parametric equation, normally written as x equal to x naught plus at. Okay, and then y equal to y naught plus bt. Okay, z equal to z naught plus ct. Okay, so t here is our parameter. Okay, how do we get this value of t? So we can put any value of t. And the most important, okay, what is our x, y, z? What is our x naught, y naught, z naught? And what is our ABC? So in order to get our equation of a line, so let's say, yeah, I can delete this one. Okay, let's say you are having just straight line. I put like this, for example. Okay, this straight line. So maybe under this x, y, z axis lah. X, y, z axis. Okay, this is our line. Okay, our line. So let's say if we know a point on this line, we know this point. Okay, for example, I put it as P. X naught, Y naught, Z naught. Okay, so we put not here to make sure that these values are known values. Okay, so this is our P. And the second one should be any arbitrary points. Let's say Q. I put Q, arbitrary point. So since arbitrary, we don't know what is actually the values of X, Y, and also Z. Can be Q, okay, position here. Can be Q here. Can be at here. Okay. Can be anywhere as long as located on our line. Okay. So let's say for this example, I just consider Q position here, for example. And this is arbitrary. Okay, arbitrary. Arbitrary. This is known. Okay. And the second thing is, if we are able to determine any parallel vector to this line. Okay, any parallel vector to this line. It doesn't matter your parallel vector located here. Sorry. Saying it. Okay. Let's say this is our vector u. u1. Or maybe quite far here. Okay, this is u2. Okay, maybe down here u3. Or maybe okay, on this line itself u4. Okay, your parallel vector can be anywhere as long as parallel to your line and you know this parallel vector. Okay, for example, I consider our parallel vector u2. Okay, u2, so I eliminate the rest lah. Can be anywhere, so I just select, let's say u2. Okay, u2, u2. So u2 here equal to our ABC. So remember, this is once again known. Okay, parallel vector to the line. Remember, parallel vector to the line. And basically, okay, we don't care about the direction. Is it the direction in to the right or to the left, opposite direction? Okay, just similar as long as parallel. As long as parallel. So if you know this parallel vector, you know a point on this line, then you are able to create your parametric equation. Okay, parametric equation. Okay, of a line lah. Just a moment. Okay. So how can we relate? How can we relate between this? Okay, between these two information, and at the end we are getting this parametric equation. So it's not too difficult basically. So come from the relation between this parallel vector. So if we are having vector u, okay, vector u is parallel to, okay, u2. So let's say I just rename as u only. Okay, vector u is parallel to our line here. So if we want to write the equation from this relation of parallel between these two vector and also line, so you have to find another vector on your line. What is another vector on this line? Can you tell me what is the vector on this line that we can get from here? What is it? Vector on this line. On this line. What is it? Class?
PQ.
PQ. Okay, even though we don't know exactly what is our Q here, okay, but we know our Q always on this line, okay, on this line. So that's why, okay, that's why you can get this vector PQ. Maybe here, maybe if your PK here, so you are getting this direction PQ, but to the left. Okay, this direction. It doesn't matter. But let's say for the sake of this illustration, I'm consider Q located here lah. So just assume. So that, okay, we know that U basically parallel to PQ. Okay, parallel. Parallel. So if we want to write the equation from this relation of parallel, so PQ equal to, let's say, we can put any parameter T, for example, multiply to our U. Okay, and this is actually your what you did during your physics, okay, experiment, okay, last time during your high school. Okay, when you are having parallel, so we can convert into equation, we need to put any constant in front of the second variable. Okay, so here, okay, we multiply vector u by this t. Let's say I'm writing like this. Okay, or you can put u equal to t multiply pq vector, also possible, but I choose this one. Okay, so what is our PQ? PQ is a vector, so you just find lah. Okay, from here we know that Q minus P. So X minus X naught, Y minus Y naught, Z minus Z naught. Okay, and since U is ABC, multiply T, so you get here AT, BT, and CT. Okay, or maybe I just put T first, like this. Okay, and then we make further calculation, simplify or expand right hand side here, we get AT, BT, CT. Okay, and since, okay, left vector is similar to the right vector, so that you can reduce lah into X minus X naught AT for the X component, Y minus Y naught for the Y component, and the third one is actually Z minus Z naught for the z component. Okay, and then you rearrange. At the end, you get lah this parametric equation. Understand? Understand? Class? Alright.
Yes.
Okay, so remember so this is your general form of the parametric equation, and don't forget T, okay, sorry. Okay, operation here, sign here always plus, plus, plus. Okay, if you are having minus, please change to plus. Okay, because not all the time you will need to write your parametric equation, but most of the cases they will provide you this parametric equation. You have to extract what is your vector parallel to this line, or maybe you have to find what is the point on the line from these parametric equations. Okay, so once again, x naught, y naught, z naught is a known value, known point on the line, and a, b, c is the parallel vector to the line. Okay, parallel vector to the line. T is any parameter. If you choose a particular value of t, for example, t equal to 0, okay, you will get what is your x. X equal to x naught. Y equal to y naught. Z equal to z naught, which is Q itself is just the same point as point P. Because you get x equal to x naught, y equal to y naught, z equal to z naught. Okay, if you choose t0. Let's say if you choose t equal to 1, maybe your point, okay, here t0. Okay, maybe if you choose t1, maybe somewhere here. Okay, so you know what is your a and also x naught, you calculate and then multiply by this one. Okay, and then you get what is your x here. Okay, so what is your y from t equal to 1? What is your z from t equal to 1? So maybe somewhere here, t1. Okay, then you substitute t negative, maybe negative 10, maybe somewhere here. For example, negative 10. So when you substitute, you get another point of z, x, y, z. That is actually your q, arbitrary point lah. Okay, but located here. And if we connect all the points here, so we are getting this line. Okay. Alright. Okay, remember plus, plus, plus. Okay. Next, symmetrical equation. For the symmetrical equation, so basically from this parametric equation. Okay, parametric equation. So by you have to change. Okay, I just use this original. So I put t equal to x minus x naught over a. Here I put t equal to y minus y naught over b. And the last one, t equal to z minus z naught over c. Okay, since the parameter t should be equal. If you choose t0 just now, as I mentioned just now, so all t here must be substituted by 0. Okay, you cannot having t here 0, here 1, here 2, cannot. You cannot having different values of t. All t must be similar. That's why if all t here similar, means that the three expressions here should be also similar. So we can write in this form of x minus x naught over a, y minus y naught over b equal to z minus z naught over c. So this is what we call it as symmetrical equation. Okay, in this form. Okay, this general form. And remember, okay, so what is your x naught, y naught, z naught? How to get this point? So you have to take a look from here. From here. And the most important, now for the symmetrical equation, the sign here they are using x minus. X must be positive. Positive 1x. Same goes to y. Positive 1y minus. Positive 1z minus. If your equation, okay, your equation of a line given from the question, they put is not positive z, for example. They put 2z. So you have to make it positive 1z. In other words, you have to factorize lah 2. Factorize 2, then you can get positive z minus another number here, then you will get what is your z naught. Okay, if you are having original, for example, 2z minus 1, that is actually still not your Z0. You have to rearrange in this general form. Okay, for example, to Z minus 1. Okay, okay, divide by 4 for example lah, for example. So you have to rearrange, factorize Z. Okay, 2. Factorize 2, and then we just need this Z, okay, positive 1 as the coefficient. Okay, and then minus 1 over 2 lah. Okay, 1 over 2. Divide by 4. And then rearrange back. Okay, this one and this one, you get Z minus half over 2. Okay, so now you are getting the general form exactly similar here. You can know what is your Z0 and what is your C, because C is part of our parallel vector here and Z0 part of our known point here. Is it clear? Is it clear? Class? Are you with me?
Yes, sir.
Alright, okay, so I go for the theory first lah. Okay, this is equation of a line. Okay, next we proceed to the angle between two lines. Okay, so as I mentioned last time, for the vector, please, to help you understand the needs of the question. Okay, what is the question asked about? So it's better for you to sketch. So just sketch. Okay, angle between two lines. Let's say this is your, okay, line 1, this is your line 2. Okay, let's say I'm drawing like this. So angle between these two lines should be here, or here, or here, or here. Okay, and theta 1 should be similar to theta 3. Theta 2 should be similar to theta 4. Because of that is actually straight line. The total here must be 180. Okay, 180. Remember that one. So since theta 1 is similar as theta 3, same goes to theta 2 and theta 4. So let's say we just focus with theta 1 and also theta 2. Okay, now take a look here. Okay, so during the question, they might ask you find the acute angle. If theta 1 is your acute angle, so means that you have to give your angle in what we call it less than 90 degree. If they ask you find the obtuse angle between two lines, L1 and also L2, so you have to give us theta 2, which is your angle more than 90 and less than 180. That is obtuse. How about if your theta equal to 90, you are getting perpendicular. This is L1, this is L2. If your theta here 90, so you are getting perpendicular lines, okay? Or what we call it, orthogonal. Okay, this is perpendicular or orthogonal. Okay, next, if your theta equal to 0, so it should be like this, L1, L2. Okay, what is your theta? Theta 0 means that both lines are parallel. Okay, both lines are parallel. Same goes to theta 180 lah. Or theta similar. Both line must be what we call it parallel. So remember this one. So okay, if we are talking about angle. Okay, so either dot or cross. Normally we use which one? Dot or cross? Dot or cross product? Anyone here?
Dot.
Dot. Can we use cross? Can we use cross? Class? Afif.
Yes, sir.
Can we use cross?
Can.
Why we choose dot compared to cross?
Because dot tak ada tu apa magnitude, tak ada direction semua.
Okay, the calculation much easier compared to cross. Okay, thank you. Okay, saya panggil seorang-seorang. Tak nak jawab kan? Saya panggil seorang-seorang. Okay, but you have to remember if you want to use dot or even you want to use cross, that formula must be in between two vectors. Two vectors. Here we are talking about lines. So now, can we know or get any vector from this line? Line 1, for example. Is it possible for us to get any vector from this line 1? Is it possible? Possible tak? Your guess. Possible not?
Possible.
Possible. Why? So what is your vector? For line 1, what is your vector? Your guess? Yani Syams Zaman. Dapat jawab ni saya bagi apa? Bagi consider bonus mark. Yani Syams Zaman. You are not here. You are not listening. Okay, your guess. You want to try? How? Don't want. Kapo? You want to try, Kapo? Tak ada.
Has vector, but L1 is vector.
Are you sure L1 is a vector?
No, the magnitude.
But L1 is just a line. A line is not a vector. L1. Line, isn't it? Just a line. Line is not a vector.
Yeah,
But how can we get?
magnitude don't have right.
Magnitude. So since L1 is not a vector, how come we can calculate the magnitude?
Oh, so you don't have vector.
Don't have vector. Are you sure? Okay, Wali, Zaga, help me. Wali, are you here, Wali? Okay, not here. Okay, Vishesh. Vishesh? Not listening. Okay, Tengku.
Yes, sir.
So, what is the
Yeah.
vector from L1?
Tak tahu.
Tak tahu. Okay, right. So, if you go back, okay, this is our equation of a line. So, what is x naught, y naught, z naught? Point on the line. What is ABC? ABC is parallel vector to the line. So, this is the vector that we are looking for. Okay, because this parallel vector is a part of our equation of a line. So from this line, you can get ABC. That is your parallel vector. Where is the parallel vector for L1? So let's say can be anywhere as long as parallel to L1. Can be quite close to the L1 or maybe far away from L1. But let's say for this case, I just consider our parallel vector located here on this line, for example, just to represent that is parallel vector. Okay, can be close, can be far away, but for this case, I put like this. This is your parallel vector. Same goes to L2, line 2. This is your parallel vector for line 2. Let's say, once again, I choose on this line L2. So, if you take a look here, you are having U1, you are having U2. Okay? Let's say like this. So, can we get this theta 1 from U1 and also U2? Is it possible?
Yes.
Right,
Yes.
so possible. Okay, now that's possible because you know already what is your vector U1 and also U2. So using our dot product lah, between U1. Okay, how do we get U1? From your equation of line 1. Okay, and then U2. Okay, parallel vector to our line 2. So you divide by their magnitude. Okay, then you can get your theta 1, for example. But as usual, so remember remarks in your dot product. If your dot product here is a positive, so you can get acute angle. If your dot product here 0, you will get orthogonal or perpendicular. If your dot product here equal to negative value, so you will get this obtuse angle. Okay, remember. So this is the formula of our angle between two lines. Okay, so proceed to C. Okay, C is intersection. Okay, now intersection. So let's say once again you are having two lines. So I put like this. Okay, quite similar lah diagram for this intersection because we are having intersection. Okay, intersection. So for this intersection, so basically we are having three sub intersection, which is the first one intersect. I'm writing down here. Okay, the second one is parallel. The third one is skewed. Okay, so maybe I go for parallel first lah. That should be easier. Okay, parallel. If these two lines are parallel, means that you are having like this. Okay, L1, L2. This is a parallel. Okay, means that if they are parallel, so go back to our idea here. Parallel. Okay, means that if we are having two vectors here, and you can relate with any parameter. Okay, but here since your equation of line, they are using T or even they are using S, for example, for the second line. They will use different parameter, S or T, for example. The most important, this concept. If you are having these two vector, you can relate these two vector by having any constant here. Okay, in other words, okay, just now you are having U1 here, you are having U2 here. Okay, same goes to here, U1, U2. Okay, it doesn't matter lah, okay, opposite direction or not. Okay, let's say I'm just consider this similar direction, for example. Okay, if you can relate U1 equal to any constant, I put lambda here, to your second, okay, second vector here. If you can relate like this, put in this relation, that is actually parallel. Okay, if you cannot write in this form, okay, or maybe U2, put 2 lambda U1. Either one lah, U1 in front or U2 in front, it doesn't matter. As long as you can put this in this form, you can take out lambda. Lambda here can be any constant. Either positive, either negative, 0 no. Okay, not 0. 0 is not what we call it parallel. If 0 means that that is just a point. Okay, if 0, you can check lah. Okay, negative, positive also can be fractional number, can be rational number. Okay, decimal number. Okay, fraction 1 over lah, for example, or 2 over 3, something like that lah. Okay, if you are able to write in this form, so this is what we call it as parallel. Okay, parallel. Okay, if you cannot write in this form, means that your two lines here are not parallel. Okay, not parallel, if not equal. Not equal. So simple lah. So I give you IE, for example, U1 from a parallel vector to the line 1. Let's say you get 1, 2, 3. And U2 equal to maybe 2, 4, 6. For this one, okay, normally we choose the largest what we call it, okay, largest vector lah, to be reduced into the smaller vector. So let's say U2 equal to 2, 4, 6. You can rewrite this as when you take out 2, 1, 2, 3. So if you can see here, 1, 2, 3 is basically our U1. Okay, so you can write U2 as 2 multiply U1. Okay, this is what I mean here. Okay, you can get this equation. So that is actually parallel. So once again, U1 is a parallel vector to line 1, U2 is parallel vector to line 2. So by using showing this, so you know that both lines are parallel. Okay, so another example, for example, okay, U3. U3 is 5 minus 1, 0, for example. Okay, and you cannot relate this one equal to, let's say, you want to relate to U1, for example. So X component, you want to make it 1. So you just take out 5. So 1. Okay, here become 1 over 5. Here become remain 0. So this is not equal to U1. Okay, in other words, you cannot write in this form of lambda U1. So if not equal, that is not possible, not parallel. Understand? Class? Clear? For parallel?
Yes, sir. Yes, sir.
All right.
Good.
Okay. Thank you very much. So I just proceed to intersect. Okay, finish this first. So if we are checking for intersection, okay, intersect between these two lines, for example, okay, if they are intersect, means that they should having this point. In other words, we call it as point of intersection. Okay, so this is point of intersection, and this point, remember, must belongs to both lines, L1 and also L2. Belongs to both lines, L1 and also L2. Okay, how can we get this point of intersection? Okay, from equation of this line. Okay, the idea is, okay, my advice, if you are having the equation for this line 1 and also line 2, please, whatever equation given, is it symmetrical or parametric, please write both equation of lines here, okay, in parametric, what we call it, parametric form. That should be easier. Okay, that should be easier. If you can write, for example, L1, okay, L1 x equal to x1. I'm using x1 plus a1t lah. Okay, so y equal to x, not y1 plus b1t, z equal to z1 plus c1t. So for line 2, if you can write in this form of parametric, x equal to x2 plus a to t, sorry, they will use different what you call it, parameter. S, for example, y equal to y2 plus b2s, z equal to z2 plus c2s. Okay, if you are having different lines, so please use different parameter symbols. Okay, one is t, another one is s. So go back to this intersection. If they are intersect, means that at this point you can get this point of intersection. Belongs to both. What is the meaning of point of intersection belongs to both? Means that this x must be similar to this x. This y similar to this y, and the last one z here similar to this z for our line 2. Mesti sama, must be similar, because that is point of intersection, belongs to both lines. So if you can write or relate, okay, x1 plus a1t equal to x2 plus a2s for the x component. For y component, equal to y2 plus b2s, and z component, so you may write in this relation, okay? So x1, y1, z1, point on the line 1. A1, B1, C1, vector parallel line 1. Okay, same goes to x2, y2, z2, point on the line 2. And A2, B2, C2, vector parallel to line 2. Means that you know all the values, okay, from your equation. But the one that we don't know here is basically our t and also s, our parameters. Okay, you don't know s and also t. If you are having two unknowns, s and also t, okay, how many equation that we require to find the value of s and also t? How many? How many equation? At least. How many?
Two.
Yes, two equation at least. If you are having less than two, so you cannot find either one, s or t. If you are having two, you can find exactly what is your s and also what is your t. If you have more, you have to check, okay, the extra equation to make sure your value that you obtain s and t just now from these two equation is correct. Okay, so in this case, you are having 3. Okay, whereas we just need to find s and also t, two parameters. So basically, okay, the technique here, you have to find s and also t values, but from any two pairs. For example, you choose this one and this one. Okay, this one, no. Okay, all right. Okay, or maybe you choose this one and the third one. This one you are not consider. Okay, maybe you are not consider the first one. You use the second and also the third equation. You can choose any pairs, okay, to find s and also t, as long as your calculation easier lah. Because when we solve simultaneously, we choose any equation that makes our calculation easier. That's why you can choose 1 and 2 or 1 and 3 or 2 and 3. Okay, you are having different options basically. Okay, so let's say if we are having this, okay, you choose this, okay, the first and also the second equation to find s and also t. Okay, you choose this one, s and t. You find the value from these two equations. Okay, you can use any techniques lah, either just conventional substitution or you can use matrix technique. Okay, matrix technique. Okay, right. Okay, and you have to remember, okay, yes, you can get s and also t, but for the third equation that you are not consider, okay, to find your s and also t here, you have to check either your s and t here is okay are correct or not. How? Okay, you substitute t here, t value here, and then you substitute s value here. If both sides for the third equation here give you the same value, for example, you get here 4 equal to 4 when you substitute t and also s. If similar, means that your s and t here are correct. Means that you are having what we call it, okay, intersect. Your L1 and also L2 are intersect. Okay. So let's say when you substitute s and t into the third equation, but you get left hand side, for example, maybe -2. Right hand side, the value when you substitute s, you get 5. Not similar. Means that s and t here are not satisfying all the equation that we are having. Supposed to be all equation must be similar because that is point of intersection. Okay, but if you substitute into the third equation, you get left hand side and also right hand side values here not similar, means that both equation are not both lines are not intersect. Is it clear? Is it clear?
Yes.
Yes. Okay. So this is how we check intersects. Okay. All right. So, and the last item for this intersection, number 3. Skewed lines. What is the meaning of skewed line? Simple. Okay. Skewed line is actually both lines are not parallel and not intersect. Okay. So means that to identify whether both lines are parallel, are skewed or not, so you have to check parallel, must be not parallel. So you cannot write in this relation. Okay, and also not intersect means that when you check with the third equation, you are getting different values on the left and also on the right. Not intersect. If not parallel and not intersect, and is not just not parallel, then you say this is skewed. No. Okay. For example, you get not intersect only, then you just direct jump to the conclusion skewed line. Cannot. Must be not parallel and not intersect, then you get this skewed line. Okay, for example, you are having like this lah. Okay, this is your one line. Okay, this is another line. Okay, and they are actually not parallel, a little bit slope lah. Okay, kind of like this. Okay, not parallel and they are not intersect, never intersect. Okay, that is skewed lines. Okay, intersection between two lines. Okay, let I finish the theory first. So I just continue the last sub topic for this line, C and D. So intersect. So this is shortest distance. Okay, shortest distance from a point to a line. When we are talking about shortest distance, okay, let's say you are having this line. Okay, this is your line. This is another point of your line here. For example, I'm using M lah. Okay, and known point x1, y1, z1. Okay, so the shortest distance should be here. And must be perpendicular. That is actually shortest distance. Okay, your shortest distance, D. Okay, if you are having a little bit slope over there, okay, so like this, for example, okay, you are having not 90 degree, this is larger than, okay, the distance is larger than compared to this 90 degree distance. Okay, so must be 90 degree. That's the characteristic for shortest distance. So we are talking about point and also this line. Okay, this line. So how can we find this D? How can we find this D? So again, my question. If you have a line, you have the equation for this line. What is the items that you can get from equation of a line? What are the information that you can obtain from equation of a line? What is it? Yeah, class? Anyone? Tang Shaun. Tang Shaun.
Yes, sir. I'm not sure, sir.
Sure? Not sure, eh? Not sure. Okay, line. Based on the equation of the line. Where is your equation of the line? Here. Let's say in this form or in this form. So can you tell me what are the information that we can obtain from this equation of line?
Vector.
Vector, parallel vector, ABC, isn't it? ABC, parallel vector. Non-parallel vector, isn't it? Another one?
Point.
Yeah, point on the line. Represented by this x naught, y naught, z naught. So this point on the line. So remember, if you are having parametric equation or symmetrical equation, so you are having these two information. First one point, the second one parallel vector. Okay, you can extract from this parametric equation, or even to construct this parametric equation, you also require these two informations. Okay, if you are not having these two information, you cannot write your parametric equation. You cannot write your symmetrical equation. Same goes to if some of the information not given here, so you cannot get, for example, what is your parallel vector from your given equation of a line, for example. Okay, remember that two information. Point on the line and also parallel vector to the line. Okay, I put here lah. Remember parallel vector. So now go back to this one. Okay, maybe parallel vector to this line somewhere, okay, off the line or on the line itself. So once again, so I just consider on the line, for example. Okay, this is your parallel vector. Okay, denoted by U lah. For example, U or V, it doesn't matter. Just for this case, I put U. And also, you know, point on the line. Where is your point on the line? So maybe somewhere here, maybe somewhere here, maybe somewhere here, maybe somewhere here. We don't know exactly. So for this case of illustration, I just consider, let's say, your point on the line is located somewhere here and denoted by P, X naught, Y naught, Z naught. Okay, right. Just for the illustration here, so I assume our P here can be anywhere lah, basically on the line. Okay, so how can we get this distance, okay, to this line? Okay, distance from point. All right. So since you know what is your P, okay, this is non point. Okay, this is known. And this point of the line also should be known, given. Okay, given. So basically you can find the vector for PM, for example. Okay, PM. And let's say, okay, this line of PM here, okay, and this original line here, so they are providing you the angle theta here, for example. So if we want to use the what we call it, okay, the information, okay, you are having this theta, you want to find this shortest distance, and you can get this vector. What kind of formula of theorem Pythagoras that we can apply here? What is it? Pythagoras theorem. What is it? Sorry?
Sin theta.
Sin theta. Okay, we use sin theta. Sin theta equal to opposite, isn't it? Opposite is D. How about your hypotenuse?
PM.
PM. Are you sure this is correct?
PM needs to be in magnitude.
Yes. We have to consider the magnitude of our vector PM. It's not just vector. Once again, okay, because our theorem Pythagoras, we are dealing with distance. It's not vector. Sin theta, cos theta, okay, adjacent divided by hypotenuse. All is about distance, length. Okay, so if we are having vector, yes, we do have the length for this vector. So by calculating its magnitude, that's why we have to put this magnitude. Okay, And then if you rearrange back, D equal to PM magnitude sine theta. Okay. You may use this formula if you know your theta. How about if you don't know your theta? Okay, remember, in between our dot and cross, as I mentioned last time, our application here, we always using dot or cross, dot or cross. Okay, between dot and also cross product, which one of the product that having sine theta in the formula?
Cross.
Cross product. Okay, cross product. And once again, remember, if we are talking about cross product, must be in between two vectors. So now we are having PM vector and also even our parallel vector U. So now we are having two vectors here. So if we can cross between U and also PM, let's say U cross PM. So using the formula from our cross product, this is our formula. Don't forget magnitude of this U cross PM. Okay, so that PM sine theta similar here. Okay, so we can represent PM sine theta as our D. So that you may write D equal to, this is your D. D equal to U cross PM over magnitude U. Okay, this is if you are not having any information regarding to your angle here. Then that is actually difficult lah, because we cannot locate precisely where is our point P here. So impossible lah for you to get this data easily. Okay, so it's better to get the distance, shortest distance between this point and also this line. So we are using this formula instead of this formula. All right, so understand shortest distance from a point to a line? Understand?
Yes.
Okay. So I think that's for our theory.